Let's starting. In this, we are going to start Master Amazon Athena. As part of Master Amazon Athena, let's start understanding what is Amazon Athena. What is Amazon Athena? Exactly. We have S3, we have S3. In S3, in S3, we can create buckets. We can create a bucket. Inside a bucket, we can create folders. Optional, we can create folders. Inside a folder or inside a bucket, we can load files. Let's say file 1, file 1. So inside a bucket, load file city. So S3 supports unlimited storage, unlimited storage, unlimited storage. It is a storage service. It is storage service. It is storage service. If I want to, if I want to write some analytic operations on this files, we can use either Python or PySpark or AWS Blue or some other programmatic approaches to perform analytics on this data. Yes or no? It is a file and it is huge volumes of file. A bucket contains huge volumes of data. So if you use traditional technologies, it will take more time to process. That's why we apply data engineering technologies to process this huge amounts of data sets. For that, we need to write a programmatic approach. Yes or no? So instead of writing programmatic approach on this data to perform analysis. Instead of writing programmatic approach to perform data analysis on this file system, AWS given one special service called Athena. AWS given one special service called Athena. Using Athena, you can write data analysis using SQL queries. Using SQL queries. Okay. On top of S3 file system. On top of AWS S3 file system, you can write simple SQL queries. You need to run any programmatic. You can write whatever till now you know SQL knowledge, right? You can write that SQL using Athena on top of S3. Let's say S3 contains file systems. How Athena knows about this file system? So for that, it uses AWS Glue Data Catalog. AWS Glue Data Catalog. Let's say AWS Glue Catalog. AWS Glue Catalog contain AWS Glue Catalog. AWS Glue Catalog contain metadata. Metadata about this file. Metadata about this file. It contain table name, file location, and column name, and data type of each column. Data type of each column. So this meta information blue contains this metadata information about this file. So whenever you write SQL, it reads this meta information and reads this file. Based on this metadata information, it reads this file. Okay. So using Athena, we can write pure SQL queries. Pure SQL queries. Amazon Athena is a serverless interactive query service. You no need to set up any mission to run Athena queries. AWS people give nice user interface where we can write SQL queries, on data presented on S3. No need to write any ETL code. No infrastructure is required. Just focus on writing SQL queries. Internally, it uses different technologies like a Presto, Rhino to process your SQL queries, to execute SQL queries on top of S3. It supports different file formats. It supports almost all file formats like CSV, JSON, Parquet, ORC, Avro. It supports different file formats, and it uses AWS Glue data catalog for metadata information. One more important point I'm going to add here is, let's say AWS Glue do not have your S3 file data, file meta information. Assume using Athena, you can create a table on top of S3. You can create a table on top of S3, then that metadata information, whatever you use, create table on S3 file system using some definition, right? That definition is going to store it to AWS Glue data catalog. You can create directly without AWS Athena. You can also create definition or meta information using AWS Athena using create command. So it's very, very, very important service in AWS data engineering. And if you want to do any analytics on S3 file system, the best service in AWS is Amazon Athena. Here we are going to use pure, pure queries, SQL queries. We never use single line of programmatic approach. We use ANSI SQL. ANSI SQL is common for every database, every warehouse, right? Similar way, you can use the same SQL on Amazon Athena. Okay, you no need to know programmatic approach. If you know SQL, you can happily work on Amazon Athena. If you do not know SQL, learn SQL and SQL is very, very easy. Clear, right? What's Amazon Athena? Yeah. Let's continue master Amazon Athena. In this, let's start understanding key features and use cases of Amazon Athena. First important one, Amazon Athena is a serverless. You no need set up any mission physically or virtually or remote. You no need to set up anything. You need a AWS account. You need a AWS account. Let's say I have AWS account. I have AWS account. Here you can search Athena. You can search Athena. Let's open it. See, this is my Amazon Athena dashboard. Amazon Athena dashboard. Here you need to select query your data in Amazon SageMaker or query your data in Amazon Athena console. This one is recommended. And click on Launch Query Editor. So this is Amazon Athena Query Editor or dashboard. Here we are going to write our pure SQL queries. Here we are going to write our pure SQL queries. SQL queries. So this is our Amazon Athena dashboard, and in this we have opened Amazon Athena query editor. Okay, yeah. Next point to do. Next important point to do. If you observe here, if you observe here, uh, it offers pay as you go basis. So what is pay as you go basis? First important point, it comes with free tier. It comes with free tier. What is the limitation? We are going to discuss in next topic. Next topic. Just understand it supports pay as you go basis. Let's say you have data in S3. Let's say you have 1 GB data. You are writing SQL query. How much data you are scanning to apply this data analytics? You can pay only for that, and that too how much time it is taken. Based on the AWS people calculates pricing. So you no need separate infrastructure, and it approaches pay as you go. It applies pay as you go basis. So you no need a setup cluster with huge number of missions, right? You are using serverless architecture, and you are paying how much data you scanned, how much time it is taken to process. Based on that, AWS people calculates a pricing. And next important, it is fast start. So when we write query, uh, you no need a separate environment for start. You just click on submit, it will work because you no need separate library to run this one. So they already set up everything. They are giving nice user interface where you are writing your queries, where you are writing your queries. So it is very fast. Whenever you submit, it will work. It will not take much time to set or load libraries. Next, very, very important one, it integrates with Glue, or it connects with Glue before processing queries on S3, because S3 contain complete file system data. So that file system related definition where we store inside a AWS Glue data catalog. So there are two approaches to create a metadata. One, using AWS Glue crawler. You can create a crawler. That crawler can connect S3 file system, reads S3 file system, identifies a header, reads sample data, identifies the data types, and stores that meta information into Glue data catalog. So one approach is Glue crawler. Second approach, in Athena, you can write direct create a table definition. So if you write a create a table definition, it is also stores that information into AWS Glue data catalog. And very, very important thing is supports giants. You may have multiple tables. You want to retrieve data from multiple tables. When data is in multiple tables, we write join operations. Yes or no? Without a join, we cannot access data from multiple tables. So Athena supports join operations on multiple files or sources. And very, very importantly, federated queries. Query data in RDS, Redshift, or even JDBC. Along with the S3, along with S3, it also supports query data in RDS, Redshift, or any JDBC supported one. With 99.9999%, we use on Amazon Athena on S3 file system. Amazon Athena on S3 file system team. Okay? Yeah. Let's continue master Amazon Athena. Let's start understanding how Amazon Athena works. Let's see high level architecture. So first data is presented in S3. S3. You may ask a question, how data comes into S3? Using data ingestion techniques. Using data ingestion techniques. Ingestion techniques. We will load the data into S3 or different applications loads the data into S3. There are multiple ways data comes into S3. First one, we have a bucket, optionally folder. Inside a folder, we have files. Star.csv, CSV files, or Avro files, ORC files, Parquet files, etc. So we load the data into S3. For a practice purpose, we are going to create a bucket. We are going to create a folder. We are going to load file manually for our practice purpose. So first, data is presented in S3. Data is presented in S3. Next one. Next one. We will create a metadata. We will create a metadata into AWS Glue Data Catalog. Glue AWS Glue Data Catalog. AWS Glue Data Catalog. Here we create a metadata. 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 Here we create a metadata. This metadata contains file location. File location. Okay. Comma. Column name. Comma. Data type. Data type. Comma. File format. File format. File format, etc. These are main important things. These are main important things. File location, column name, data type of column, file format. It contains this metadata information. Metadata information we will create using crawler, using Glue crawler. Glue crawler. Okay. One thing, we can create crawler. Crawler can reads S3 file, stores this metadata information, or inside Amazon Athena query editor. Inside Amazon Athena query editor, we can write create a table command. Create a table command. Table command by pointing this S3. Then this create a table command also stores metadata information. So first schema in blue data catalog. How schema is going to create in catalog? One using crawler or other we create a table definition using Amazon Athena. So that plus blue data catalog contain definition of this file. That's one. Query engine. Query engine. Amazon Athena contain query engine. Query engine. Here we write SQL queries. Let's say I am writing SQL query. SQL query. Let's say select query. Whenever I clicked on run button, Amazon Athena query engine responsible for connecting this blue data catalog, understanding this definition, understanding this definition, and connects to your S3 location, process your query, and generates response. So query engine in Amazon Athena is responsible to process. Finally, output to S3. Output to S3. Here we are going to see inside query editor, we are going to see output, but this output, where it is going to store is, we will give a path of S3 location. Let's say we are going to create a separate bucket for our Athena outputs. Let's say Athena outputs. In this Athena outputs folder, we configure. So once I said query engine going to execute the query, right? It generate a result, right? That result it is going to store it into S3 location, only result. Then you can see output of this result in Amazon Athena console. Amazon Athena console. Okay. So in this way, Amazon Athena works. Hope you understand these four important steps of Amazon Athena. First point, first point, why we are going for S3 bucket is it supports unlimited storage. There is no limit. There is no limit for S3. There is no limit for S3. Let's say I created folder for employee. Let's say I'm storing monthly data. Let's say last month one data, this month one file, today one file, tomorrow one file. Like that, we can store all employee related same structured data into this location. You can store any size of data. There is no limit. Unlimited. Yes, yes, yes. Usually, usually, usually we use S3 for storage of data. That's why we connect multiple sources, we store the data. S3 is reliable, it never fail. You can access this data. You no need separate backup mechanism for S3. S3 supports unlimited storage, 100% reliable and durable. And only one thing, if you want more reliability, you can configure multi-availability zone. So sometimes, let's say, assume uh, uh, we have selected Mumbai region and we selected availability zone North Mumbai. Assume entire North Mumbai suffering with floods, earthquake, or some other natural disaster. Then that availability zone may not available. Then you can choose that to more reliable. You can select a multi-availability zone. So it never fail. It never fail. So, yeah. Yes. Let's start continuing Amazon Athena. Let's start understanding Amazon Athena pricing model. Using this Amazon Athena, you are writing SQL queries. Then we have discussed Amazon Athena is a serverless. No need to set up any server or no need to create any mission for running your queries, right? So, how Amazon people calculate pricing for your queries? Okay, let me discuss here. Let me discuss. Let's say, let's say, uh, we are writing queries in Athena. Athena. Let's say in this Athena, we are writing select query. Okay, and let's say star, and the table name is sales, sales. Okay. Here we have S3 bucket. We have S3 bucket. We have S3 bucket. Here, let's say bucket name sales bucket, and in this we have a sales folder. Sales folder. In this, let's say we have file one. Let's say file one. This file one, let's say it contains 1 GB data. 1 GB data. So let's say we are applying this select query on this data. Then how Amazon people calculate pricing for this one? How Amazon people calculate pricing for this one? First, your data size. Next one, how much time, how much time your query ran. To process this one, it may take fraction of seconds. Yes or no? So understand query execution. For $5 per 1 TB. $5 per 1 TB. So expect how much for your 1 GB data? Very, very, very minimal. Yes, sir. Let's say after again you are running this query. This time you have one more file. Let's say 10 GB data. New file, 10 GB data. So data ingestion team ingesting data into this location. Let's say daily they are ingesting. Daily they are ingesting data. At particular time, they are ingesting data into this location. Day by day, data is growing. One day, 1 GB, 10 GB, 5 GB, 3 GB, 2 GB, 20 GB. Like that, data is growing. Data is growing. Data is growing. Not like anything into this sales location. Every day sales happening. If it is festival, more sales happens, then you are going to get a big file. Yes or no? If it is some special day, sales happens more, then you will get some more big file. So all the files you are storing into sales folder. So whenever you write a query, how much data this query is scanning, based on that they calculate. For 1 TB, they are going to charge $5. Okay. And I said here it is going to connect blue data catalog. Blue data catalog. Blue data catalog for meta information. Okay. So first free 1 million per month, 1 million request. If you send this request for connecting this blue data catalog, right? How many times you're going to send? 1 million regards 1 million times connections are free, requests are free a month. After that, they are going to charge based on the do data catalog pricing. Next one thing, I want to reduce pricing. I want to reduce. Let's say this one contain 10 TB, 10 TB. I am writing queries like this. I am writing queries. Select star from sales where where city city equal to city equal to Hyderabad. City equal to Hyderabad. Let's say in this 10 DB data, just 10 GB data is Hyderabad data. 10 GB data is Hyderabad data. But for this 10 GB, we are reading entire 10 DB data, 10 TB data. So your cost is too high. Then how can we reduce? We have a concept called partitioning. Partitioning. You can create a partitions, city-wise partitions. City-wise partition. Hyderabad one partition, Pune one partition, Bangalore one partition, Chennai one partition, Mumbai one partition, Noida one partition. Like that, you can create a multiple partitions. Multiple partitions, nothing but subfolders inside main folder. Subfolders inside a main folder. But while creating a table, you can give indication to Athena. Hey Athena, our S3 contain different partitions. So if you write these kind of operations, it will go directly to particular folder and reads the data instead of entire data so that you can reduce cost of Athena. Cost of Athena. And other approach to another way to reduce cost is along with the partitioning, we have different compression techniques, columnar techniques. If you store data in Parquet format, it is a columnar format, fast reading, fast processing. And we have compression techniques like Snappy and different compression techniques so that at a time we can read more data, compressed data, and compression instead of 10 GB, it will become a 1 GB. If you use compression techniques like Snappy, we have different compression techniques. So low level into compression, then it reduce your data size so that you can reduce cost. First one, first one, actual data. To reduce cost, we use partition. To reduce more cost, we do compression. To reduce more cost, we use different format types like a columnar format called Parquet. So these are different techniques to reduce cost of Amazon Athena. For our simple queries, it is free. But when you work with real organizations like healthcare sectors, banking sectors, finance sectors, their data is huge volumes. So they do these kind of different techniques to reduce the cost. Okay. Hope all of you understand Amazon Athena pricing model. Yeah, sure. Correct. You are 100% correct. Let's say, and yes, perfect, correct. Bucket. Inside a bucket, we create a folder, let's say, sales folder. Inside a sales folder, we create a partitions, correct. Hyderabad one partition, one folder, HYD one folder, and in this we store dot packet for reducing cost. Another, yes, yes, correct. Here we use another folder, then here we use Chennai, correct. Let's say here we are writing create table. In create table, we can say in create table we can say this file, this sales data contain partitions. We give a information here while creating definition. While creating definition, we say our input location contain different partitions based on city column. We give a information to partition by column name. Column name. Correct. Same as our regular RDBMS style. Same as our regular warehouse style. We provide a definition. That is different. This is different approach. Yeah. See, this is query engine, right? Query engine, right? This is already query engine. Instead of Glue, PySpark, we are using Athena for writing queries. Again, you want to go with the complex. To reduce complexity, we are coming to Athena. Whatever we do with Athena, we can do with Glue, Python, PySpark, everything. But those are programmatic approach. To reduce that one, we are coming to Athena. We are writing simple SQL queries. Again, you are asking to go that yes, you can do, you can do. You can apply all your SQL skill set. Already optimization, we are creating partitioning. We are creating partitioning and we are using compression techniques. We are using compression techniques and we are also using columnar format like Parquet format. Then it is already giving a best performance for you. Still, you want to apply any SQL techniques to optimize? Yes, you can write a SQL techniques to optimize query execution time. Apply your all SQL skill set. Yeah, that's why it is very good feature in AWS cloud team. Maybe other clouds maybe have it, but in AWS for doing data analytics, we usually go with Athena on top of S3. No need to go, no need to write any programmatic approach. You can directly write SQL queries. Yeah, one of our friends said filter condition city equal to Hyderabad and city equal to Bangalore. Two partitions you are going to read. Yes. So whatever filter condition you are going to add, based on that, it is going to connect with the particular partitions. So based on that, it is going to generate a billing for you. So instead of reading 10 TB data at a time, we are using partitioning, we are using compression, we are using columnar format to reduce data scanning so that we can reduce cost of Amazon data. Let's start in this session, as part of Master Amazon, let's start writing first Amazon Athena SQL query on CSV in AWS S3. Okay. So here, what I'm doing, I'm going to create one bucket. In that bucket, I'm going to create a file. In that file, a folder. In that folder, I'm going to place a file. Okay. Let me first open my datasets location. In my computer, in, in C drive, I have datasets folder. In this, I created one folder called Athena. In this, you can see website traffic file. Let me open this file. So this is input file. It contains user ID, timestamp, page URL, from where visitor is coming, and then country of visitor. Okay, this is my website traffic details file. So first, I am going to create bucket, S3 bucket. So here, I am going to create S3 bucket. Let's see, uh, here, create a bucket. Bucket name I am giving Sreenivasa, let's say AWS DE hyphen Sreenivasa, uh, let's say Sreenivas hyphen Athena. Then uncheck this option. I acknowledge. Then create a bucket. In this bucket, in this bucket, uh, in this bucket, let's create a folder called website underscore traffic. Let's create a folder called website underscore traffic. Create a folder. Okay. Then create folder. Inside this folder, place a file. You just go that folder location. Okay. Let's say this is mine and this is folder. Let's just drag this website traffic folder and place file. Okay. Click on upload. Click on close. Click on close. You can see file is uploaded. Okay. First part S3 part is completed. S3 part is completed. Now, remember, we can create metadata information using glue crawler, and the second one, create a table. So we are going to see creating external table. Okay. So here, see, I'm going to create a website traffic table, and whatever columns I'm seeing here, I provided column details. Column details. Let's take this one. Let's take this one. So going to query editor, and here, see, if table is not existed, create a table. Okay. Next one, and each column name data type, each column name data type, each column name data type. Next one, and my file contain column delimiter is comma. Every row separated with new row, new line. Yes or no? New line. So I am providing those details here. See here, row format, Saturday. There is a predefined class in Athena called Open Saturday predefined class. This class is responsible to read this file and identifies this information. And I am giving a class. This file contain comma separator, and this one contain header. We are providing header details, right? Then while anyone execute select query, keep this header. Next one. This file is presented in S3 location in a text file format. Location of this file is, tell me, this is my file bucket name, AWS hyphen Sreenivas hyphen Athena. This is my file location, bucket location. Under that bucket, there is a folder called website underscore traffic properties. There is no encrypted format. Okay. I am providing this definition just to create a table. And one more important part. One of our friend asked, do we need to create a bucket first? Sorry, database first. Yes, correct. Let's say you are working for project one. So for every project, we create a separate database. For every project, we create a separate database. So here, if you see, already I have created a database name Sreenivasa underscore DB. If it is not created, you have to create. Okay. So see, there is no table. There is no table website to traffic. Once you execute this one, you are going to see table. Now, if you observe here, run button is disabled. Run button is disabled. Why? If you remember in how Amazon Athena works, I added one point. Can anyone tell me? If anyone tell me that point? So once we execute Athena query, it is going to persist, right? Whether table is created or not, select query executed or not, how many records it written, that kind of result, right? So see, we have to create a separate bucket for loss of Athena. Let's create a log, create a bucket. In this bucket, I'm giving AWS DE hyphen Sreenivas hyphen Athena hyphen logs. Okay, uncheck this one, then create a bucket. Okay, I acknowledge. Okay, create a bucket. Now go to Amazon Athena. Go to Amazon Athena. Scroll up. Scroll up. Here you can see edit settings, or you can see query settings. Click on edit settings. Click on edit settings. If it is not coming, let's go to query settings. Okay. So scroll down. Click on okay. Go to saved queries. Go to recent queries editor, and once again click this editor. Edit settings. Before you run, you need to set up this one. Click on edit. Okay. Query settings. Go to manage. Click on browse S3 and select our bucket. AWS Sreenivasa hyphen Athena hyphen logs. Then click on choose. Click on save. That's it. Now you can go editor. You can select, see, run button is enabled. Select this query. Click on run. See, here it is going to, yeah, 1 minute. Execution error, returned code 1, and see DDL task, illegal exception, illegal character at this location. Okay. Amazon Athena. Go to here. Yeah, here. New line, right? Yeah. Sorry. Let's select once again this query. We can run button. You can see run query. The query is completed. You can see website underscore traffic table is created. Now I want to read this data. Now I want to run queries. Let's see, you can run any SQL query. Let's say select star from website underscore traffic. Then select this query, control enter. See, you got complete records. You can apply any SQL query, on this table. Okay, clear writing, how to create a table, how to run queries, how to configure S3 log location for storing the results. Yeah. Let's starting. As part of Amazon Athena, in this session, let's see creating table for a Parquet file with compression and partitioning in Athena, then apply SQL queries. Okay. Let's observe the benefits of this approach too. Yeah, first one, we are going to create a S3 bucket. In this S3 bucket, okay, in this S3, we are going to first create a bucket. Under bucket, we are going to create a folder. In this folder, we are going to create different partitions. Partition 1 and partition 2, partition 2. Okay, like that, we are going to create multiple partitions and so on. Partition N. Partition N. In this partition, we are going to store file in the format Parquet file. That Parquet. We store file in the format Parquet plus this file we store in compression format. So what is the benefit we get in this way of storing the data? Let's say if I am using Athena query editor for for reading this data, so here we write SQL query. Earlier in same S3 bucket, we created a bucket, okay, and we created a folder. In this folder, we loaded complete files. File. So observe, if I execute SQL query, let's say select star from X table where where year equal to let's say 2025, year equal to 2025 and month equal to month equal to 3, and uh, and day equal to 20. Day equal to 20. Let's say I want to this data. I want to this data. Assume here this file is 1 TB data. 1 TB data. Earlier, previous queries reads entire data, but here we did partition based on year, month, and day column. So let's say uh, 2025 March day 20 contain just 1 GB data, 1 GB data, and that too compression format. Let's say compression is it converted, let's say MB's data, MB data. Then if you scan, how much data we are scanning? Just MB of data in a S3 location. Previous approaches, it's a TB data. So cost of your SQL query is high compared to this partitioning and compression. So same query only. We are not changing anything. We are applying same query on previous approach and current approach. Current approach reads only MB of data. Previous approach reads entire data. So in this way, we can improve performance of the application, Athena query, and save cost of your SQL query execution. Okay. Yeah. Let's implement this one thing. Let me in this, let's see here. We are going to take a file sample underscore data underscore snappy dot parquet. I have already did a compression format. Let me show file in my C drive under datasets under Athena. Here you can see sample dot snappy dot parquet file. Using different approaches, I have converted this one. So I already shared this datasets to you. Go to S3 location. Okay, S3 location. Then here, let's see here, AWS hyphen Sreenivasa hyphen Athena. In this, what I'm doing, I am going to create a folder called Parquet. See, I am going to create a folder called Parquet. Create a folder. In this Parquet folder, I am going to create a subfolder called year year equal to 2024. Create a folder year equal to 2024. Then create inside this subfolder, create a folder for month equal to 004, month equal to 04. Create a folder. Okay. Then in that month folder, create a subfolder called day equal to 10. So this data is related to April 2024, April day 4 data. Okay. So let me open any online Parquet viewer, Parquet viewer online. Let's take any one Parquet viewer. Let me open a file under C drive, under datasets, under Athena. This is my sample Parquet viewer file, Parquet file. See, you can see timestamp. In this timestamp, you can see 2024 and month is 04. In that month, we have day 10. All records are day 10 records. So I created a same style and I am going to upload data into in this location. Just take this file and drag this file into this location. Okay, then click on upload. Click on close. Click on close. Okay, yeah. So in this bucket, we have this data. This is my bucket name. Okay, so let me give a bucket name. In this bucket, we have data. Okay, so this is my bucket name. In this bucket, we have the data. Yeah. So here, let me create a table for this. Okay, so I am creating a table analytical parquet. Let's first go to Athena. Okay, go to Athena. In Athena, I am creating a table. Table name is analytics underscore parquet. Column names are user ID, timestamp, action, platform, partitioned by year equal to int, month equal to int, day equal to int. Then stored as a Parquet format where it is presented in this location. And table properties are the file is in Parquet format and compression technique used is snappy. So while creating table, we are giving all these details to Athena. So there is no table analytics underscore Parquet. Let's click and run this one. You can see a table is going to create analyticals underscore partition, and you can see compared to other tables, here you can see extra is partitioned. This table is partitioned compared to all other tables. It is super fast and it reduces cost of your Athena SQL query. Okay, next one. Now I am writing SQL queries. I am writing SQL queries. Before doing any SQL query, we have to give a indication to Athena. Hey Athena, my bucket contain different partitions. Then understand what are partitions means subfolders. So here we given a column names, right? Partitioned by year, month, day, right? So it is going to check the subfolders inside a bucket and understand the partitions. So for that, we are giving indication to Athena say MSCK repair table analytical parquet. So when we apply this one, it checks our S3 location and understands the partitions details. Let's execute this one. Then it gets all the partitions information. See, year equal to 2024, month equal to 04, day equal to 04. Added partition to Metastore Analytics Parquet. Are you seeing this message? Yeah. Now you can write You can write where condition or filter condition. Then this query directly goes to particular partition, reads the data instead of reading entire data. Instead of reading entire data. It is super fast. We are not seeing complete difference previous query, this query. But if you apply same thing for GBs of data, TBs of data, petabytes of data, you are going to see clear difference. What is the difference we can expect? One is faster execution. Second one is cost reduce. When you run SQL query, it instead of scanning TBs of data, it is scanning MBs of data. Because your data is compression format. Clear, right? How to create Parquet format, how to create a table with the Parquet format, with compression, with the partitioning. Okay. Let me explain, let me continue master Amazon Athena. In this, we are going to see loading JSON data into Amazon Athena table. So we seen CSV format data, we seen Parquet format data. Now let's see load JSON data into Amazon Athena table, then write SQL queries. Okay, let's create a folder, JSON folder in our S3 bucket. So this is my bucket, AWS Sreenivas Athena. Create a folder. Folder name is JSON. And in this JSON, we are going to load a JSON file. So in my location, you can see sample underscore JSON, sample underscore nested underscore JSON. Let me open this file. See, so you can see different JSON records. I am going to load this JSON file. Click on upload, click on close, and then let me create a table in Amazon Athena to read JSON format data. If you remember, for CSV, we have a CSV SERD class. Similar way, for JSON, there is a predefined class JSON SERD predefined class. Can anyone tell me how JSON data looks like? Anyone having idea about JSON? It starts, a record starts with curly braces and ends with curly braces. Here we have key, comma, key colon, value. A key colon value pair separated with comma. Let's say comma. Another key value pair. Key to colon value to, and so on. And so on. In this way, JSON data is presented. This is for one record. Another record, comma, another record. JSON. So in this way, we can see different records. So there is a predefined class called JSON SERD. This class knows about this JSON data. So if you give your S3 location, then this JSON class is responsible to identify the structure of your data. Okay. Now I am creating a table called create external table user sessions with all column names. Then I am giving location of my S3 bucket, S3 bucket JSON location. Let's create a table. So you are going to see user sessions table. Now I am writing SQL query. So we are getting particular record. Clear, right? How to create a table for JSON format data, and query writing query is common, SQL query. Once a table is created, we can write SQL queries. Yeah. Let's continue master Amazon Athena. In this, let's continue. Next important topic is views in Amazon Athena. Any idea views? It may be RDBMS, it may be data warehouse. What is the purpose of views? Usually, what is the purpose of views? Can anyone correct? We have a table with a table, a table with multiple columns, multiple columns, okay, and multiple rows, multiple multiple rows, multiple rows too. So we do not want to give complete access of this table. I want to create a window. I want to create a window. Example, in our home, instead of showing entire house, we will open a window. Then some part of house we can see through the window. Similar way, we can create a view, view 1, view 2, view 3, and view 4. Like that, we can create view n. In this, I can give some columns access, all rows. In this, I can give some columns, but few rows only. In this, I can create another view. I can give some columns and I give only some rows with some other conditions. So like that, we can create multiple views. This view I can give to analytic 1 team. This view I can give to analytic 2 view. This view I can give to analytic 3 view, analytic 3 team. So that if they query on this view, then they get data from this table. A view is a saved SQL query. Saved SQL query. You can query like a table. The downstream people, they do not know it is a view. They, sorry, one moment. Let's continue it. So we will create a view to expose a part of table data instead of giving complete table access. We will create different views and we will write different conditions, means SQL query. That SQL query internally going to talk with the table to get match records. Instead of exposing complete table data to everyone, we can create views. It is similar to same as RDBMS or data warehousing style tip. There is no different. Okay, let's start creating a view. Let's say I have one data set called user events in my uh, location. Let's say this is my user events. So I'm going to load this user events data into user events table. On that table, I am going to create views. Let me uh, explain process. So first, I am going to create a table. I am going to create a table. Let's see. This is my bucket name. This is my bucket name. So let me create a bucket. Sorry, create a folder, views folder. And in this views folder, I'm going to upload a file, user events file. Let me upload this file, user events file. Then once we upload it, then go to uh, Amazon Athena query editor. Then first create a table. First create a table for it. So I am creating a table, user events table, to point to this folder. And this file format is CSV. So I am using CSV Seridi class to know about this input file format. Then I am giving path of my CSV file in external location called S3 location. So then I am writing select query on table. Select query on table. This select query gives complete rows and columns. So I do not want to give this complete rows and columns to everyone. Instead, I want to create a view. I want to create a view. I want to create a view. So create or replace view. View name is recently login and type is event type is login. So event type is login. I am creating view only for login people. Then a analytics team. This is a table or view. You can access and present these details to your report. Then I am executing this one. Then it is completed. Then downstream going to use this query to access the table. But backend it is connecting user events table. So we are backend team or downstream team going to execute this query. But this query internally going to communicate with whom? Actual table. So they are getting only who logged in, who used logged in. But we are not exposing all columns. We exposed only few columns. So whatever our downstream expecting, same format, we created a view, we given view to downstreams. So like this, you can create nested views. for different conditions. Okay. So clear right now? What is view? How to create a view?